This is the first picture of the Earth fully illuminated that any of us ever saw. It was taken on the last of the Apollo missions, and it changed the way that humanity thought about our common home. It reminds us that we are all connected and that our actions have an impact on our planet. There are only three questions remaining about the climate crisis. Must we change? Can we change? Will we change? First of all, must we change? The scientific community all around the world has been telling us for a long time that yes, we must change. Now Mother Nature is telling us. The sky is not a vast and limitless expanse the way it appears to us as we stand on the ground and look up. In reality, there is just a thin shell of atmosphere surrounding the planet. We're putting 152 million tons of man-made global warming pollution into the atmosphere every single day. That pollution, especially carbon dioxide, is building up and is trapping heat. Here's the basic science of global heating. This has been understood by scientists since the 1800s. Energy from the sun comes to the Earth in the form of light. That light is absorbed by the Earth and warms it. Some of that energy is re-radiated from the Earth in the form of heat. Some of that outgoing heat is trapped by the atmosphere, which is a good thing. It has kept our planet at a stable temperature. Now, however, we have been thickening the atmosphere by filling it with heat-trapping pollution. More heat energy is trapped, and it is warming our planet at an unprecedented rate. There are many sources of human-caused global warming pollution: agricultural practices, forest burning, transportation, and many other factors. But the main source and cause of the rising temperatures in the globe we are seeing today is the burning of fossil fuels. Fossil fuels still provide more than 80% of the world's energy. Fossil fuel use and emissions have gone up dramatically since World War II. In the last few years, there was a leveling off as the world adopted more and more clean energy solutions, until another recent spike in global warming pollution. As a result of this pollution being trapped in the atmosphere, global temperatures have risen dramatically. 19 of the 20 hottest years ever measured with instruments have occurred since 2001. The hottest year of all was 2023. Beyond the information I have in this slide, because it's so recent. Heat itself is a problem in many parts of the world and in many parts of this country. Heat affects not only people, but animals, crops, and our weather. On a global basis, more than 90% of all the extra heat energy trapped by our atmosphere is going into the oceans. This heat makes ocean-based storms like hurricanes, typhoons, and cyclones stronger and more destructive. Half of the increase in global ocean heat content has occurred in less than 20 years. Hurricane Florence produced record-breaking rainfall across portions of North and South Carolina when it made landfall on the morning of September 14, 2018, near Wrightsville Beach, North Carolina. The extra heat also disrupts the water cycle. The amount of water vapor that evaporates off the oceans increases as the oceans warm. That water vapor is carried over the land and often falls in much bigger precipitation events. When the land can't absorb all the water that falls in these large storms and downpours, we see floods and mudslides. Extreme precipitation events have produced more rain and become more common since the 1950s in many regions around the world, including much of the United States. Extreme precipitation events lead to record flooding, which has been occurring all over the world. Like in Brazil this past May. Sometimes people wonder how global heating can be blamed for causing more precipitation and flooding and at the same time more drought. The extra heat trapped by rising levels of greenhouse gases actually leads to both, and as the climate changes, precipitation patterns also change, leaving some places with less rainfall than before. Changing precipitation patterns can lead to drought and water shortages. Southern Brazil, for example, suffered a devastating drought in 2015 and 2016. Higher temperatures also have a direct effect on the incidence and severity of wildfires. Here see that the number of large fires corresponds closely to years with higher average spring and summer temperatures. Today, the fire season in the western United States is more than 100 days longer than in the 1970s. In 2016, this fire in the heart of the Canadian tar sands region destroyed large parts of the city of Fort McMurray, Alberta, and forced the evacuation of over 100,000 people. The number of climate-related extreme weather events has been going up worldwide, according to the insurance industry. The last 2 years rank among the top 10 most expensive for overall disaster losses, with over $160 billion in losses in 2018 and $140 billion in 2019. The first photo is of a glacier in southwest Greenland that was shot in the summer of 1935 and shows glacier ice covering the fjord walls. The second photo is the same glacier, which had almost completely melted by 2013, not even a century later, due to rising temperatures. NASA has precisely measured the decline in mass of ice in both Greenland and Antarctica. All this extra melting is raising sea levels worldwide. Miami is the number one city at risk in terms of assets at risk, along with Guangzhou, China, New York, and others. Looking at cities and risk by population, we see that many huge cities in developing countries are very much in danger. If parts of these cities become uninhabitable, where will the people who live there go? The Department of Defense of the United States has long warned about refugee crises connected to the climate crisis, as well as pandemic diseases, water shortages, and food shortages. Heat stress is now beginning to decrease crop yields from rice, corn, and soybeans. Exposure to higher levels of carbon dioxide also decreases the nutrient content of many staple crops such as rice, wheat, and soy. Infectious diseases, heat stress, air pollution, and waterborne diseases are all influenced by a changing climate and not in our favor. Warmer temperatures have an impact on the spread of tropical diseases. Modern transportation and air travel play a part, but the potential range for many diseases expands as regions farther and farther poleward get warmer. This means there are more and more places where a disease like Zika can take root. And so, do we have to change? Yes, we do. But what about the second question? Can we change? The answer to this question is very, very exciting and positive. We've got the solutions available to us now. Look, for example, at renewable energy. Wind energy was predicted to provide 30 gigawatts of electricity worldwide by 2010. As of 2019, we had exceeded that prediction by 22 times over. The growth in wind energy being built around the world is an exponential curve. And wind energy could supply 40 times more electricity than the entire world currently uses. Solar energy is an even more dramatic story. 18 years ago, the best projection was that we would install 1 gigawatt of solar energy capacity per year by 2010. By 2010, we exceeded that goal by 17 times. In 2019, we exceeded the goal by 121 times. And even more dramatically than with wind, we see an exponential curve in the amount of solar energy installed around the world. Just as we have seen with other technologies such as computer chips and cell phones, solar costs have fallen dramatically. In some regions, solar energy is less than half the cost of electricity from burning coal. In many countries where there's no universal electricity grid, we are seeing consumers and businesses leapfrog old technologies and install solar panels in places that have long been denied access to electricity. Chile is a true solar success story thanks to its policy decisions. The country's solar market took it off slowly, but look what's happening now. At the end of 2018, Chile had 2.3 gigawatts of installed solar and has an additional 16.67 gigawatts of solar projects approved or under construction. There are many regions in the world where this type of growth and development are possible. Every hour, the Earth gets as much energy from the sun as we need to run the entire global economy for a year. If we can increase the fraction of this energy that we harvest and use, we can make a lot of progress towards solving the climate crisis and helping local economies at the same time. Battery storage is an essential part of the green energy revolution. Batteries allow us to store excess solar or wind energy and use it during those times when the sun isn't shining or the wind isn't blowing. Batteries are also critical for the electric vehicle market. In 2016, the global cumulative storage capacity approached 3 gigawatts, which is almost 2 times the storage capacity seen in 2011. As storage technologies get more efficient and cheaper, the market is growing quickly. Global cumulative storage capacity is expected to reach over 900 gigawatts in 2040. Within the next 8 years, highly efficient LED lights are predicted to virtually take over the market. Energy efficient technologies like LEDs save people money and help to reduce emissions by cutting down on the amount of electricity we use. I worked for a year in 2019 helping to install LED lights here in Southern California with a company called SolarBox. All these automobile manufacturers are now offering or preparing to offer electric vehicles. This is another part of the sustainability revolution. So can we change? Yes. What about the final question? Will we change? Here too, there's exciting news. In December of 2015 at the Paris climate negotiations, every nation in the world agreed to phase down greenhouse gas pollution to net zero emissions as early as in the second half of this century as possible. We're seeing marches and demonstrations and demand at the ballot box for the changes necessary to solve this crisis. I'm a volunteer with Citizens Climate Lobby, and we've come up with a proposal called the Energy Innovation and Carbon Dividend Act, which would get us to net zero by 2050, provide affordable clean energy. The money collected from the corporate polluter fees go directly into the pockets of millions of hardworking families via a monthly carbon cashback payment. The money can be spent without restrictions, and most low middle income Americans will come out financially ahead or break even. This policy will help improve health and save millions of American lives over the next 50 years by reducing pollution Americans breathe. Poor air quality from burning fossil fuels is responsible for as many as 1 in 10 American deaths today and sickens thousands more. So look it up and be a part of the solution. Write to your congressperson. Use your voice, your vote, and your choices in the marketplace and in your life. Speak truth to power, like your world depends on it. Because our world depends on it, and we need your help. To learn more about the climate crisis and what you can do to help solve it, please consider seeing the film An Inconvenient Sequel, Truth to Power, or reading the book. Thank you. This is Edward Rivero.